In this video, we are going to discuss how to calculate the wavelength and frequency of electromagnetic wave. The question says, what is the wavelength of green light that has a frequency of 5.70 times 10 to the power 14 Hertz? And they have said use C equals 3 times 10 to the power 8 meter per second. Now, light is an electromagnetic wave. So sometimes instead of mentioning electromagnetic wave, they say green light, red light. But you must remember speed of any electromagnetic wave. No matter what the color, no matter what the frequency, speed of all electromagnetic wave is the same, which is c, 3 times 10 to the power 8 meter per second. This value of speed may not be directly given to you in the question like what they have mentioned here, but it is given in the table for constants. So whether they mention green light, red light, or they mention ultraviolet wave, radio wave, all of them will have the same speed c, which will be 3 times 10 to the power 8 meter per second. So let's write down what the question has given us and what are we expected to find. I have the frequency of green light, which is 5.70 times 10 to the power 14 Hertz. Speed of light is 3 times 10 to the power 8 meter per second. I need to find the wavelength lambda. The rule for wavelength is lambda equal C over F. Now this is a very direct question. I will just substitute the values here. C is 3 times 10 to the power 8 divided by the frequency, which is 5.70 times 10 to the power 14. And when you solve this, you get the wavelength to be equal to 5.26 times 10 to the power negative 7 meter. Sometimes they ask you to convert this wavelength from meter to nanometer. A nanometer is a prefix which has a power of 10 to the power negative 9. If I want to convert from meter to nanometer, just multiply your value in meter with 10 to the power 9. And when you will do that, you will get the value of lambda in nanometer. So let's do that. I will multiply my value of lambda 5.26 times 10 to the power negative 7 with 10 to the power 9. And when I do that, I get my answer as 526 nanometer. So to convert from meter to nanometer, we multiply with 10 to the power 9. And if I wanted to convert from nanometer to meter, you will divide by that number. So speed of electromagnetic wave c is a constant. This value remains the same for all electromagnetic wave. So no matter what wave they give you, whether it is radio, X-ray, red light, blue light, whichever light they give you, they will all have the same value of C, which is 3 times 10 to the power 8 meter per second. So do not get confused with the color given to you in the question. No matter which light they mention, they must all have the same speed, C. Let's discuss another question. Here the question is asking you, what is the frequency of an electromagnetic wave that has a wavelength of 2.2 times 10 to the power negative 2 meter? And again, they have given you the value of C. So let us first write down what we have. I have the wavelength lambda 2.2 times 10 to the power negative 2 meter. Speed of light c is a constant, 3 times 10 to the power 8 meter per second. I want to find what is frequency f. So we know the rule for lambda. Lambda equals C over F. If I want to find F, we need to rearrange this term. So I can just cross multiply this F and lambda. I can move F here, bring lambda at the bottom. Or you can create a triangle for this expression. Since it has only three terms, I can use the triangle method to rearrange them. How do you put your terms in the triangle? If you have a ratio, start with the ratio. Whichever quantity is on the top, I will write here on the top of the triangle. So C is on the top of the ratio, so we write C on the top. Below C comes F, and then you have your lambda. So I want to find what is frequency F. And when you find frequency F from the triangle, F is C over lambda. So let's write F equals C over lambda and substitute. C is 3 times 10 to the power 8. Lambda is 2.2 times 10 to the power negative 2. And when you solve this, you get your frequency as 1.36 times 10 to the power 10 Hertz.